look for greatest common factor, you're going to have to think, does this have two terms? And if it does, are they perfect squares? Because if they're perfect squares, we factor by the difference of two squares. If not, then we have to look at it and say, okay, it has three terms. Is the leading coefficient 1? Because if a equals 1, the factors that you choose are the factors that you're gonna use. But if a does not equal 1, then you have to factor by grouping or make a box. So there's a lot of steps. So I'm going to try and give you some hints to know where to go because I think it can be overwhelming, right? So step number 1, I think the most important thing is anytime you get a problem like this, the first thing that you want to check for is, you are so amazing, thank you so much, is look to see, is there a greatest common factor? That's the first thing that you want to do. And then you want to check, are there two terms and they're separated with a minus sign? Two terms separated with a minus sign. I didn't realize I was frozen. So sorry, guys and gals. Two terms separated with a minus sign. So number 1, GCF is exactly what it says. Two terms, difference of two squares. But remember that when we do that, they have to be separated by a minus. They have to be perfect squares separated by a minus. If they're both perfect squares, but they have a plus, we can't factor it this way, okay? If you have three terms, look at the first number. Is a 1 or is a greater than 1? Four terms, we automatically factor by grouping. So we're going to do each problem nice and slow, and we're going to write out what we're looking for. So number 1, do you see a GCF? So GCF is, say it again, is 4. So that means I'm going to divide both of these terms by 4. So remember, when I pull out a GCF, I put it down at the bottom, because if I don't put it at the bottom, what do? I forget it. You'll see, actually, if you looked at answer number 10, I had to wipe that out and rewrite it. Because I did not write my GCF down. Pick your head up, please. Come on. Okay. All right. So once I take a 4 out of both of those terms, I'm left with x squared minus 1. Is x squared a perfect square? And remember, variables are perfect squares if their exponent is even. So it's a perfect square. Is the number 1 a perfect square? Yeah, it is. 1 is made by taking 1 times 1, right? So let's see. Well, hang on a second. It's the difference of two squares, right? It's the difference. That's how this is called, the difference of two squares. So we take the square root of the first term, which is x, and we take the square root of the second term, which is 1. And do you guys remember how we did this? We put a plus in one binomial and a minus in the other. So this one is important because I want to check this to make sure that you remember how to do it. And I'm just going to check by using the FOIL method. So x plus 1 times x minus 1, and then I'm going to figure out what that is and multiply everything by 4. So let's see. X times x is, okay, a positive x times a negative 1 is negative x. A positive 1 times a positive x is a positive x. And positive 1 times negative 1 is negative 1. These are unique because what happens here? What happens right there? They cancel out. So you're left with x squared minus 1, the difference of two squares. So if I were to multiply through by 4, I would end up with 4x squared minus 4. So this is correct. So I'm going to put DOTS because it's the difference of two squares. The difference of two squares. Okay. So I want you to look at the next example and remember what I said about variables being perfect squares. Is x to the fourth power a perfect square? Yes. X to the fourth is a perfect square. I'm going to write perf square because the exponent is even. Whenever the exponent is even, that's a perfect square because that means you have to think about your exponent rules. So let's see. What is the square root of x to the fourth? That's just saying what number do I multiply by itself to get x to the fourth? Well, let's see. If the base is the same and we're multiplying, we just add the exponents. So it has to be a 2. So the square root of x to the fourth is x squared. You just divide that exponent by 2. Now I need to think about what is the square root of 81? 9. So it's going to be x squared minus 9, x squared plus 9. Okay. Now I'm going to pause for a second and I'm going to ask you, is this completely factored? Or do you see another difference of two perfect squares, difference of two squares in your factors? Yeah. Yeah. So this one I cannot change. This one is going to stay the way it is. But this one is the difference. See, that's the difference. Subtract means the difference. The difference of two squares. The square root of x squared is x. The square root of 9 is 3. So it becomes x plus 3, x minus 3 times x squared plus 9. So I would say that dots, the difference of two squares, is probably the most common multiple step problem that you're going to see because it's the easiest for us to write. So whenever you see two terms, the first thing I want you to do is say, are they joined by a subtraction sign and are they perfect squares? Because if they are, you factor it this way. Okay. If they're not joined by a minus sign, you can't change it like this. This was not joined by a minus sign. We cannot reduce that. Good with that? Okay. The next one has 4 terms. What do we do when we have 4 terms? Factor by grouping. So this is a grouping. G-R-O-U-P. This is a grouping. So x cubed, oh my gosh, plus 2x squared minus x minus 2. I'm going to group these together. So what can I take out of the first one? I can take out an x squared. So when I take an x squared out of the first grouping, what do I have? I have x plus 2. What can I take out of the second grouping? I need this to end up being x plus 2. And right now it's negative x minus 2. Yeah, I have to take out a negative 1. I have to take out a negative 1. Negative x divided by negative 1 gives me a positive x. Negative 2 divided by negative 1 gives me a positive 2. Now, do I have my copycat? I do. My copycat is x plus 2. And do I have what's left over? What's left over? X squared minus 1. X squared minus 1. That looks a lot like what we started with up top when we took out our 4. So what is this? What's x squared minus 1? It's the difference of 2 squares. So what does that mean? Well, that means that this can be factored again, right? We're going to factor this again. So the x plus 2 does not change. But what is the square root of x squared? X. And what is the square root of 1? 1. So it becomes x plus 1 x minus 1. They're hard to see sometimes, right? They're hard to see sometimes. So you have to remember, whenever you have two terms, if they're both perfect squares, yes, Brian, thank you. That's how you factor that, okay? You're just going to have to look for that. Two terms, if they have a square on it, see if they're different to two squares. Okay. What about number 7? Guys, I want you to pick your heads up. We're not laying down here. This is important. I want everyone to pick their heads up, or I'm going to make you guys start coming and standing next to me. I love the company. So what are we going to do with this next example? What can we take out? What do you see that we can pull out? Is there a greatest common factor here? Yeah, see. It's written for you right here. So what did I do? The last thing I did was what? So this cannot change, but this gets broken up into x plus 1, x minus 1, because this is the difference of two squares. So I'm going to take a 7 out. 7, 7, 7 from everything. So when I take that 7 out, I hate the way that pen looks. My pens do not work, so I'm using a fat foamy thing, and it's horrible. So when I take a 7 out, let's see, what do I have? This leaves me with x cubed, y minus x squared y plus 3xy minus 3y. Is there something else besides that 7 that I could take from every single term? What? No? Yes? What? A y. Yeah, I could pull a 7y out. So I'm going to take out a 7y. So here's what I'm going to do. I'm just going to scribble this out. Get rid of the y's. So now I'm going to group it. So my 7y is going to come down here so I don't forget about it. What comes out of this? X cubed and x squared. What can I take out of both of these? I'm going to take out an x squared. So when I pull that x squared out, I'm left with x minus 1. What can I take out of here? The next grouping. A 3. When I pull that 3 out, I'm left with x minus 1. So copycat comes out first, x minus 1 times what's left over, x squared plus 3. Yes. Are we good with that one? Still writing it down? You good, Austin? Okay. All right. Next one. What are we thinking? Okay, you're not even on the right page. I want you to come to that. You're just sleeping. Come on, pick up your stuff right up here. Let's go. You're standing with me at my table. So do we have a GCF here? Yes or no? Is there a GCF? Is there a greatest common factor? Something we can pull out? Here, Zach, you can put your stuff right here. So you just got a table. All right there. What else is there besides that one? There's a 3. Yeah, every term is divisible by 3. So we're going to divide everything here by 3. Divide by 3, divide by 3, divide by 3. So right here. Divide by 3, divide by 3, divide by 3. That's where you are. So when I divide everything by 3, I'm pulling that 3 out, and I'm going to put it down here. Let's see. when I divide this first term by 3, I'm left with x squared. Negative 3x divided by 3 is negative x. And negative 60 divided by 3 is negative 20. What's my leading coefficient? What does A equal? What does A equal? That's this value right here. This is A. 1. So what do we know when A equals 1? The factors that you put in that times plus that work out are going to be the ones that you pick for the times plus or the ones that you use. The factors that you use are the factors that you choose, or the factors you choose or what you use. It doesn't matter how you say it. So times plus 1 times negative 20 is negative 20. Has to add up to a, what is that going to be, Logan? What two numbers can I multiply together? Peyton, what do you think? What two numbers can I multiply together to get negative 20 that when I add, I get negative 1? Negative 1 times 20 gives me negative 20, but when I add that, I get 19. I need to add it together to get negative 1. What are numbers that you multiply together to get to 20? Aren't 2 and 10 going to work? Here, let's see. I can take 2 times 10, negative 5 and positive 4. Good job. Negative 5, positive 4. Since my leading coefficient is 1, the factors that I choose, God bless you, are the factors that I use. So it's x minus 5 times the quantity x plus 4 with that 3 out front. What about this next example? Is there a GCF in this? Look carefully. Is there a GCF here? 4. What? 8. What else? What does every term have? An x. So we can divide everything by an 8x. Divide by an 8x. Okay, so I'm going to pull that 8x out front so I don't forget about it, because if I don't pull it out, I will forget about it. Let's see, 40x cubed divided by 8x. Well, 40 divided by 8 is 5. X cubed divided by x is x squared. Thank you. What about 24x squared divided by 8x? 24x squared divided by 8x. What is that? Plus 3x. And negative 16x divided by 8x is what? Is negative 2. The x's cancel out. Just right up. Thank you, ma'am. So let's look at our times plus. Let's look at our times plus. So sign back in for me, please, and thank you, Brian. Times plus. So 5 times negative 2 is negative 10. Daniel, are you awake? I can't see your eyes. I hate your hair like that. I can never see your eyes. What's the B value? 3. Daniel, it's just because you have nice eyes. It'd be nice to see them every so often. What two numbers can I multiply together to get a negative 10 that when I add them, I get a positive 3? Is that weird that I said he has nice eyes? Is that weird? Okay. He does. What two numbers can I multiply together to get negative 10 that when I add them, I get a positive 3? Let's see, factors of 10. 10 times 1 or 5 times 2, right? That's it. So one of those has to be positive, one has to be negative. Positive 5, negative 2. So this has to be done by grouping. because my leading coefficient is not 1. So 5x squared plus 5x minus 2x and minus 2. So let's do our grouping. So what can I take out of the 5x squared plus 5x? Yeah, I can divide everything by a 5x. So when I pull out a 5x, what do I have left? Looks like I have an x plus 1 left, correct? What about the next grouping? I need it to equal x plus 1. So what am I going to pull out? A negative 2. Divide those both by negative 2, and I get x plus 1. Copycat comes first. What you have left over, 5x minus 2. These are the factors of that example. These are the factors. Tell me if we're ready to go on. Okay. This is our last one. What about here? What can we take out? How many a's out? What power is the a that I could take from everything? Yeah, I could take an a squared out of everything. Divide everything by a squared. I thought that I could take out a 6, but 13 is not divisible by 6. So I'm taking out an a squared. So let's see. That leaves me with 6x squared minus 13x plus 6, because these just cancel out. That's sweet. So let's see. Times plus. 6 times 6 is 36, has to add to negative 13. What are we thinking? Any ideas? How could I find these factors? Y equals what? Negative 4 and negative 9, yes. Negative 4 and negative 9. If we did y equals 36 divided by x and went to the table, we would get these. So let's see, I have 6x squared minus 4x minus 9x plus 6. What can I take out of that first grouping? I can take out a 2x. So 2x. 6x squared divided by 2x leaves me with what? 3x. And negative 4 divided by 2x leaves me with negative 4x divided by 2x leaves me with a negative 2. What can I divide this by? A 3. So let's see. I'm taking out a positive 3. Negative 9x divided by 3 is negative 3x. Is that what I want in here? A negative 3x? Is that going to give me a copycat? Right. Say that again, Zach. Was that you? Who said that? Was it Logan? Say it. That means that we got to take out a negative 3. This needs to be a negative 3. Do you guys see that? Because otherwise we're going to end up with a negative 3x, and that is not going to provide us with a copycat. So we're taking out a minus 3. Negative 9 divided by negative 3 is positive 3. Bring down your x. Positive 6 divided by negative 3 is negative 2, and that gives us our copycat. If we don't do that, we don't get the copycat. So you have to watch that. So I have a squared times the quantity of 3x minus 2 times the quantity of 2x minus 3. And that is it. That is it. So I want you to look at the worksheet on the next page. Look at the worksheet on the next page, and we're going to pick problems. I originally said like do odds or whatever, but we're going to pick problems, and I'm going to write hints by them. So I want you to do number 2. And I'm going to tell you right now, this has a GCF. And I want you to do number 5, and I'm going to tell you that this has a GCF. And I would like you to do number 6, and it also has a GCF. And I'm looking at the methods. Let's see, are there any difference of 2 squares? 7, I want you to do 7. 7 has a GCF. And then I want you to do 11. Yeah, I'll write them out in a second. And then we're going to just drop down to number. Hang on. I'll write them all out in a second. I wanted to see what type of problem they are. I want you to jump down to number 18. This has a GCF. And that's different. And then 19, you can choose to do 19, 20, or 21, 22. You guys decide. Yeah, 8. So let's make a choice. Do you want to do 19 and 20 or 21 and 22? Someone decide right now. So 19 and 20. There we go. So I'm going to tell you all the problems that you're doing. Okay. So you are going to do number 2, and it has a GCF. You are going to do number 5. It also has a GCF. You are doing number 6. It has a GCF. Number 7 has a GCF. Number 11, it has a GCF. Number 18, it has a GCF. Number 19 and number 20. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 problems. It's way better than the 12 that I had assigned to you. Okay. So I took a third off for everybody. You're welcome. So 2, 5, 6, 11, 18, 19, 20. Daniel. Yes, you may. I'm going to go to Canvas and fix the assignment that's in there because I don't want you to think that you. Yes, sir. Yes, you may.
Did 19 and 20 not have GCF?
You don't have to do those. You only have to do the ones that I circled. Oh, 19 and 20 don't have GCFs. No. Yes, that's your homework. If you get it done, you're done. Ma'am. Yes, you may. Sign out, please, and thank you. Six, 7, 11. Yes, sir.
If this is how you would start out the problem.
Which one?
Number 2. Would I
Yes.
divide every single one?
Yep.
Or,
I would divide everything by 7 first.
so then,
You have x squared minus x minus 2. So times plus negative 2. Have to show your work. Okay. So can you take a GCF out? You can. You take out a 5 from everything. You can also take out so we're gonna write that off to the side. That's coming out. So those are huge numbers. Okay, so 5x to the 4th divided by 5x squared is just x squared. Do you see that? 35 divided by 5 is 7x. 150 divided by 5 is 75. The x words cancel out. That's way better to work with. Negative 75 adds up to a 7. So do you need to use your calculator for that? Does that help you? Okay, you don't do x divided by, you do the number divided by. Oh, that wasn't you? Okay. So negative 75 divided by x. So those are your factors. Let's get you some. So we have 25 and negative 3. That's not going to work, right? You have, what's that? 15 and negative 5. You have more than 15 and negative 5. So maybe you don't. 75, let's see. 1, 75, 3, and 25, and 15, and 5. Yeah, that's it. So this is factored as it can be. You cannot factor this anymore. So it just goes in here. So your answer is 5x squared. You have to show it. Parenthesis. And then this, x squared plus 7x minus 75.